Grade 11. So we're now going to do another example. This example, we want to prove that a line is a tangent to the circle. So we're going to do page 260, exercise 8, number G. So the first thing that they tell us in the little blurb is that GBC is a tangent. So this line here is a tangent to the circle. And they also tell us that B1, which is sitting over here, is equal to E1, which is sitting over there. So those two angles are equal. And we need to prove, firstly, that E1 is equal to E3. So let's have a look at what we've got. E1 is equal to E3. Let's identify them firstly. So E3 is there and E1 is there. So I need to somehow prove that those two are equal. I don't think that's too difficult. Okay, we've got a tangent. So let's use our tan chord and see what we come up with. So if that's our tangent GBC, we also have this as our chord BA. And if we have that angle there between the tangent and the chord BA, and if we take it to the top, then that angle there is going to equal that angle there. B1 is going to equal E3. But they told us that B1 is also equal to E1. So there we have it. Done. That is equal to that, tan chord. That is equal to that, given. So then logically that angle is equal to that angle. E1 equals E3. Good. So we're done. Now let's go and look at the second one, the second example that we need to do. The second thing we need to prove, okay, let's maybe just mark what we've already established. We've established that that is equal to that is equal to that. Might help us in the next example. Now, the second thing we need to prove is that AB, this one here, is in fact a tangent to circle EAF. Now, I think it's very useful to actually visualize this, to draw ourselves a circle through EAF. It's not done 100% accurately, but basically if we drew a circle through EAF, and if we needed to prove that BA is a tangent or AB is a tangent, then essentially this would be my tangent and this would be my chord in circle EAF. So it's very useful to try and work out which angles we're actually trying to work with. There's no center here, so I can't use the radius 90-degree tangent one, the converse of that, but I can use the tan chord theorem, work with that and work with it backwards. So essentially, if that BA was a tangent, then this angle here would have to be equal to that angle there, not so, because if that's true, then BA, in fact, is a tangent. So that's our aim, is to try and to prove that BAF, this angle here, is in fact equal to that angle there. So now let's have a look. At the moment we've got the little green angles. That's all we've proved so far. But let's go back to our green one. Let's say if that's little green one, then that's also little green one. Would you agree? Because of angles subtended. That goes there. DC takes an angle up to E1 and DC also takes an angle up to A2. So those two little green ones are equal. What about using that same theorem again? We have A1 here, which forms part of the angle I'm trying to prove that's equal. So A1, where's A1? Where's there another angle also equal to A1? If you take A1 back to CB and you take CB up, we have E2. So that means that A1 is equal to E2. Can you see that coming from the same arc, angles in the same segment? I'm just going to draw it. It's becoming very messy, but I want you to focus on the blue now, okay? So what we've got in effect is we've proved it, because this purple arc here is equal to a blue and a green, and this purple arc here is equal to a blue and a green. So in fact, we've proved it. It's now just a case of writing it all up. So I want to just show you what I've done here in this little scenario here for the second one. What I have done is I've actually explained what I've tried to do. So we're required to prove that AB is a tangent to EAF. So I would like you to picture a circle through EAF. Actually draw the circle. And then we need to prove that FAB is equal to FEA. And that's what we were labeling right at the very beginning. We were trying to prove that FAB, this one here, was in fact equal to FEA, this one here. So it's a case of identifying what you are trying to prove. And then you do all your little workings on the sketch, and then you end up tying it all together. What I've done is I've used X's and Y's. You don't have to, but I find it much easier to work with X's and Y's. So have a look at the memo and then try a few more